All right, so our first lesson here, it's actually a review. I'm just going to post kind of a reminder on how to graph both cosine and sine. So here at the top, you notice this is our basic form of a periodic function. This one happens to be cosine, but it's the same with sine. So you could have a coefficient of the function out here. On the inside, we have b, which is our coefficient of x, d, which is always being subtracted from x, and c, which is always being added to the function at the end. These four letters affect our wave in this way. Our amplitude is the number a, so whatever this number is, that will be our amplitude. Oftentimes we consider amplitude always being positive, but I wouldn't mind if if this number right up here was like a -3, you could write the amplitude as negative. That's fine. Horizontal shift, this is going to be shifting your function to the left or right. That's actually d, so whatever it's always the opposite of the number that's in here. So if it's -2, the horizontal shift would be to the +2 direction, or right 2. The wavelength is always 2 pi divided by the coefficient of x, so in this case it's divided by b, and the vertical shift is whatever is added to the outside, so c. So let's do a quick example, and then we'll do another one with sine. Again, this is review, so hopefully this is a bit of a reminder. So let's graph f of x equals, we'll do 3 cosine of pi over 2 x minus 1, and we'll add 5. Okay, so to graph, I would like you to draw your own axis, just because I think it's a lot easier. So in this case, what I would do here, here's our axis right here, and here's our horizontal one, which I generally put as a dotted line. I mean, it doesn't really matter though. So this dotted line is going to be the middle of our wave. Where's the middle of our wave? Well, okay, so what's the information we need? We first need the vertical shift. Well, as we said before, the vertical shift is the c. So in this case, vertical shift is 5. 5 is going to be the center of our wave. Then let's look at our amplitude, which is 3. This means that from 5, we're going to go down 3. So 1, 2, 3. This is going to give us to 2. But we're also going to go up 3, which gets us to 8. All right. So that's the vertical shift and amplitude. The vertical shift and amplitude basically tells you what your vertical axis is. Now let's figure out what our horizontal axis is. Well, first we need to figure out where we start. Usually we start at 0. However, this actually has a horizontal shift. So we're actually going to start at 1. Now, we need to figure out what the wavelength or the period, so oftentimes it'll be a p. So wavelength and period are totally interchangeable. They're the exact same for both. But what they are is it's 2 pi divided by b, which in this case is pi over 2. Meaning 2 pi times 2 over pi, since dividing by a fraction, we would like to multiply by its reciprocal. This makes it easy because the pi's cancel and we have a 4. So now my wavelength is 4, meaning if I start at 1, how long is it going to take me to get to the end of my wave? Well, it's going to take me 4 more units. So if it takes me 4 more units, that means I'm going to get to 5. How do you figure out what's in the middle? Well, actually, this one's going to be really easy, but if they were more complicated numbers than 5 and 1, one way to figure out, well, what's the middle number right here, is you can just add them and divide by 2. So 5 plus 1 is 6. 6 divided by 2 is 3. 3 plus 1 is 4. 4 divided by 2 is 2. 3 plus 5 is 8. 8 divided by 2 is 4. Now, obviously, 1, 2, 3, 4, 5, we could have figured that out without doing the averaging of the two numbers, but averaging always works and works with much more complicated numbers, so it's kind of nice to see. Now, this is a cosine, and as you know from your unit circle, your cosine function starts at the top. So we're going to start at the top, we're going to go to the middle, we're going to go to the bottom, we're going to go to the middle, and we're going to end at the top. And so this is a single wave of our cosine function. Now, obviously, it's only one wave. The whole point of using periodic functions like cosine and sine is the fact that they actually do continue, right? So this wave would in fact continue, but I'm only asking you to graph one wavelength, but it would in fact continue that way and continue this way forever and ever. But we only need one wavelength, and that's how you graph cosine. Let's do another one. This one I'm going to actually not have a horizontal shift. And I'm going to use sine. So let's do, there we go. Let's do f of x equaling, we'll do negative 10 sine of, let's do negative sine of, how about 3? There we go. And then on the inside, we'll say, not a horizontal shift. Let's do a horizontal shift here. X minus pi over 6. Close that, and then we will add 4. Okay, so we're going to do vertical. So this has a vertical shift. It's 4. This has an amplitude. It's negative 10. So again, so negative 10 right here. Vertical shift means we're going to go up 4. Now, oh, sorry, I just messed these up. So vertical shift is 4. So this right here, the middle is a 4. Sorry about that. The middle is a 4. The amplitude is negative 10, which means I'm going to go up 10 and down 10. Just do the absolute value, So even though the amplitude is negative, you are going to go up 10 all the way up to 14, and all the way down, subtracting 10 gives me negative 6. Awesome. I'm gonna have a little coffee here. Okay, back on. Right, now let's do our horizontal axis, which we have a horizontal shift. Our horizontal shift is pi over 6 to the right. That means we're going to start at pi over 6. Our wavelength is 2 pi over 3, which we can't reduce that. So in fact, it's just 2 pi over 3. So how do I figure out where this wavelength is actually going to end? Well, if I started at pi over 6 and I went forward 2 pi over 3, I'm going to end up by just adding the two of them. So if I add these two, this, by the way, is 4 pi over 6, giving me 5 pi over 6. Right? 1 pi over 6 plus 4 pi over 6 is 5 pi over 6. So this must be 5 pi over 6. Strangely enough, this actually is, so now that these are both in terms of pi over 6 and pi over 6, this is 1, and this is 5 pi over 6s. And so really, we can just average 1 and 5. 1 and 5, the average of 1 and 5 is 3. So this right here would in fact be, that middle number right here, this right here would be 1 plus 5, which is 6. 6 divided by 3, or 6 divided by 2 is 3. So we're going to have 3 pi over 6, which obviously to us is really pi over 2. All right, this is 1, this is 3, that makes 4. 4 divided by 2 is 2. This is going to be 2 pi over 6, which is pi over 3. This is 5, this is 3, that's 8. 8 divided by 2 is 4, so this is going to be 4 pi over 6 right here. But when I reduce that, I'm going to get 2 pi over 3. And there we go. This, by the way, is a negative sine. So since it's negative sine, sine, as we know in our unit circle, starts at 0, which for us, since we had a vertical shift, is 4. It goes up to the top, but this is a negative. So instead of going up, this thing is actually going to first go down, but then it's going to go up and then back to the middle. So we get our wave graph that looks like this. And we can, if we wanted to, we realize that the graph would actually continue both to the right and to the left. So that is how you graph both sine and cosine. So hopefully that was a little bit of a review. Those are pretty much as hard as we're going to get. There is, let's actually do one more. I want to do I'm going to do one more here. Okay, so last one we're going to do is not going to have a horizontal shift. I'm going to have a cosine function here. So I'm going to do f of x equals, we're going to do maybe 0.1 cosine of 20 pi we're going to do 20 pi x and we're not even going to have it. So we're going to graph this. So vertical shift, as you can see, is actually 0. Horizontal shift is in fact also 0. Your amplitude is only 0.1, and your period or wavelength, so we'll do the wavelength. Wavelength is 2 pi divided by 20 pi, which is 1/10. Wavelength is how long it takes for one wave. So this would take 1/10 of a unit of time. So let's say if x was in seconds, this would be 1/10 of a second. So we actually have, 1/10 of a second is a tiny amount of time. So instead of talking about a wavelength having instead of a wave having a wavelength, when it's super tiny, oftentimes we will describe this with a frequency. So F stands for frequency, and the frequency is simply 10. It is in fact just the reciprocal of your wavelength. So if the wavelength is 1/10, the frequency is 10. If the wavelength was, for example, if the wavelength was 1/50th, the frequency would be 50. So that's an easy way to go switch. You just do the reciprocal of the two. Okay, so back to our graph though. This one's a fairly simple graph, so we'll do a middle line. This middle line is in fact our vertical shift, which our vertical shift is 0. We have a horizontal shift, which means we start at 0. Our wavelength is 1/10. Half of 1/10 is 1/20th. Half of 1/20th is 1/40th. Now, how do I get this third one? Well, if this distance right here is 1/40th, then this would be 2/40ths, and this one would be 3/40ths. If we continued, this would be 4/40ths, and we note that 4 over 40, in fact, is 1/10. So we actually ran into the correct final distance here. Now, our amplitude is 0.1, so we're going to go up to 0.1, and we're going to go down to -0.1. And this is a cosine, it's positive, so we're actually going to start at the top, go to the top, go to the middle, go to the bottom, go to the middle, go to the top. And this would continue on if we wanted it to, right? And so that is your first wavelength though, or a single wavelength of this particular function. So when your coefficient is really large, like 20 pi, your wavelength is going to be super tiny, and your frequency will actually be kind of large, and it makes more sense to describe this wave using a frequency. In any case, so that's just a reminder of how to do cosine. We're going to get to cosecant and secant next.